Hello, so this is the code for problem J5. I have it ready. We can go through it and write. But before that, let's learn how pair works in Python. So a pair has two elements. The first and the second. It can also be used as a key value pair. So in Python, a pair is in brackets. We can have like 1, 2. So this is a pair. We can declare a variable for the pair, and when we access the first element and the second element is similar to how we access an array. So in Python, a pair is like a two-element array. So to access the first element in pair A, we can use the index, and for the second element we have this. So this is how we access the elements in a pair. So what if we have a list of pairs? Let's reassign A to a list with the first pair and the second pair. So now we have list A, which has two pairs. So what if we want to access the first element in the first pair? So we use the index to access it. So how do we access the second element in the second pair? Same thing, we use the index. So this is how a pair can be used in Python. And now let's go through our code for this problem. First, we read in the rules. So the first three lines, we have the rules. We declare an array for the three rules, and we loop 3 times. And each time we read in a line, and we split the line to two parts. The first part is the text to be replaced, and the second part is the new text. And we put the two parts in a pair and put it into the array. So in our code, each rule is a pair. And then we read in the fourth line, which has the number of steps, and the initial text and the final text. So we read in the line, and we split the values, and for the first value, we convert it to an integer for the number of steps, and then the second value is the initial text. The third value is the final text. And after we read in the input, and we need to initialize the data structure. As we said in the analysis, the data structure is a list of pairs, and in each pair, the first element in the list and the second element is the text after this step. And in the empty list, it should be a list of pairs, and in each pair there are two numbers. The first number is the index of rules, and the second number is the position in the text where the rule is applied. And now we define a function. This function is for each step. So when you call the function once, we go forward with a step, and we accept variable which is in this data structure, and we return a variable which is also in this structure. So for each item from the input, we go through the text character by character, and for each position in the text, we check every rule to see if they can be applied. So if from each specific position, if they match the first part in the rule, that's the text to be replaced, and then we know this rule can be applied here. So we copy the sequence of the pair of rule index in the positions, and we add the current rule index in the position. And then we build a new string which is for the text after the application of the rule. And we put the sequence of steps and the new text to the variable that is to be returned from the function. So after the loop, the variable after has all the possible steps and the new text for each step. And then we know the number of steps we need to do, so we do a loop and call the function. And after this loop, results should have all the possible final text and also has the track of steps. And then we go through results for each item. We check whether the text matches the final text from the input, and if they match, then we go through the list of steps. That is how we get to the final text from the initial text. And from each step, we get the rule of the index and the position in the text. And we redo this step. We build a new string with the rule. And then we print the rule index, the position in the text, and the new text. Here, as we know, the rule index starts from 1, and also the position starts from 1, so we increase both of them for the output. So after this loop, we already get one possible solution, so we can stop here. So this is how we solve the problem. Now let's run the program against the samples from the problem. So here I have the sample here, and I'm ready to run the program. And if we put the input here, press enter, we get an output which is not the same as the output from the sample. From the sample, there is another option. We compare them, and they do not match either. So there are more than 2 possible sequences of rules and positions for this input from the sample. Let's analyze our output. So we have initial text AB, and we have final text AAAB. And we have 4 steps, so in the output we have 4 lines. That's correct. And for the first line, we apply rule 2 from position 1. Rule 2 is AB to BB, so we get BB. And then for BB, we apply rule 3 at position 1, and we get AAB. And then for AAB, we apply rule 1 at position 1, so we get ABB. And then for ABB, we apply rule 3 from position 2, so we get AAB, which is the final text. So even though our output is not same as the output from the sample, but our code is working correctly. So this is the resolution to this problem. So this problem is a little bit complicated. If you have any questions, please leave a comment down below. And if you have not subscribed to my channel, please subscribe. I'll see you soon.